Hi everyone, and welcome to today's tutorial. In this video, we will be diving into the world of LeetCode and solving a fascinating problem together. I'm excited to guide you through the process of solving the minimum absolute difference in BST problem. So let's jump right in. The intuition behind this problem lies in the properties of binary search trees and the power of in-order traversal. We know that in a BST, the in-order traversal visits the nodes in ascending orders. And by taking advantage of this property, we can compare each node with its previous node during the traversal, calculating the absolute difference and keeping track of the minimum difference encountered so far. Now, let's break down the code step by step and understand each line of code in detail. First, we define a class called solution and to encapsulate our solution code. Inside this class, we have a method called getMinimumDifference that takes the root node of the BST as input and returns the minimum absolute difference between any two different nodes in the tree. And within this method, we initialize two instance variables, prevNode and minDiff. PrevNode will keep track of the previously visited node during the in-order traversal, and minDiff will store the minimum absolute difference encountered so far, which we initialize as positive infinity. And we then define a helper function called inOrder to perform the in-order traversal of the BST. This function takes a single parameter, node, which represents the current node being visited. Inside the inOrder function, we start with the base case check to ensure that node is not none. If it is not none, if it is none, we stop the traversal as we have reached a leaf node. And we recursively call inOrder on the left child of the current node, traversing the left subtree. And this step allows us to visit all the smaller nodes before the current node. And next, we compare the current node with the previous node, starting from the second node and by checking if a prevNode is not none. If it's not none, we calculate the absolute difference between the current node's value and the previous node's value. If this difference is smaller than the current minimum difference, and we update minDiff accordingly. And we then update prevNode with the current node as we are moving to the next node in the traversal. After that, we recursively call inOrder on the right child of the current node, traversing the right subtree. This step allows us to visit all the larger nodes after the current node. Once we have defined the in-order function, we call it with the root node of the BST to start the in-order traversal. Finally, we return the minimum difference as a result of the function. And now, let's analyze the time and space complexities of our solution. The time complexity of our solution is big O of n, where n is the number of nodes in the BST. We need to visit every node once during the in-order traversal to calculate the minimum absolute difference. The space complexity of our solution is big O of h, where h is the height of the BST. This is because the recursive calls in the in-order traversal are placed on the call stack. In the worst case, where the BST is skewed and its height is equal to n, the space complexity can be big O of n. However, in the average case for a balanced BST, the height is typically big O of log n, resulting in a space complexity of big O of log n. Congratulations! You have successfully learned and implemented the solution to the minimum absolute difference in BST problem. Understanding the power of in-order traversal and leveraging the properties of BST has allowed us to efficiently solve this problem. I encourage you to continue practicing and exploring more LeetCode problems. The more you practice, the more you will strengthen your problem-solving skills and become more proficient in algorithms and data structures. Thank you for joining me in this tutorial. I hope you found it helpful and insightful. If you have any questions or suggestions, please feel free to leave a comment below. And don't forget to like this video and subscribe to my channel for more programming tutorials. Happy coding and thanks for watching. Goodbye. Thank you.